All right. So I'm going to take you through our plans for the next 2 years. Not too much detail, more of a high-level overview. We will have several sessions that take like a deeper look into some specific subjects. As always, everything we do is guided by our vision. By linking the past to the future, we provide OpenVMS users an opportunity to protect and realize the full value of their application investments. And everything that we do is done in order to enable our customers to be able to keep running their applications that they have invested a lot in. The agenda for this morning, I'll take a bird's eye look at what we're doing, then I'll zoom in a little bit. I'll talk about the base OS. I'll talk about the open suite of products, OpenSSL, OpenSSH, LDAP, and I'll have some miscellaneous for you. So last year, I explained that this is what is driving our development efforts. Our overall goal is to get as many customers who are able to go to OpenVMS x86. And to do that, we want to retain all the core strength that OpenVMS is known for. Its reliability, its resiliency, its security, its adaptability, availability. This robustness to us is something that we need to keep having in OpenVMS. Otherwise, you might just as well go to some toilets. At the same time, we do need to adapt because the world around us has been changing and we need to change with it. And the world keeps on changing, so in the future we will doubtlessly have to make adjustments and keep adapting again. We want to fit into an existing infrastructure, existing application landscape. That means we want to run where other workloads run. If your company runs all their workloads in the cloud, you need to be able to run in the cloud. It also means that our applications in OpenVMS need to be enabled to talk to applications that are on other platforms through the use of open source libraries or whatever is required to do that. We need to enable customers to port applications, whether they're their existing applications that are coming from Alpha, Titanium, or even from the VAX. But they may also need to be able to port some open source components from other operating systems to enable that integration with their other applications. And finally, we need to deliver improvements in areas like performance, ease of system management, system monitoring, our documentation, things like that. So this was last year. Today, I want to highlight what we're focusing on in the short term. So our focus right now is in these 4 areas. It's versatility. We are all about offering customers options. Customers who want to run on-premises, customers who want to run in the cloud, customers who want to run some hybrid environment. Our focus is on enabling that. We have a focus on modernization. We need to be ready to play in the modern world. And with an aging VMS knowledgeable workforce, it becomes important that people who come from different operating systems, the first time they're confronted with an open VMS system, we need to make sure that they're not going to throw their hands in the air, back away slowly, and then start scanning where the exit is. So, yes, we need to keep the strength that OpenVMS is known for, but we also need to modernize a little bit so that the younger generation sees something that doesn't look quite as dinosaur-like as OpenVMS sometimes comes across. I'm very fond of dinosaurs, but I don't We're going to also have some focus on maintainability because we are ourselves in the process of sharing knowledge from an older generation of VMS software engineers to a younger generation of engineers who have no background in that, who have never run into Fetch Macro or List before. And so one of the things that we are doing is in key areas of the operating system, we're going to make sure that we maintain our ability to maintain the operating system for you. If you report a bug and whoever gets assigned to fix that bug in the operating system, if they first have to pick up a List primer and start learning what is this language all about, it's going to take a while before your bug gets fixed, and we need to prevent that from happening. And the same, of course, with improvements. If you want to make improvements, you don't want to wait too long. We have to waiting in some kind of time. And a strong focus coming time is going to be performance. You need to improve performance for real-time or for real-world workloads. We can do all sorts of synthetic testing and show you that if you have an application that does a certain thing a million times, we have now made some improvement to that particular bit of the operating system, and that now runs 10 times as fast. Great. If that's something that you do once in the lifetime of your application, when you start the application, it's going to be that part of your application start functionality process. So, and this is something that Claire is spending and will be spending a lot of time on the investigations around this. So he has a presentation later today that goes into some of his findings. If I just want to raise a little tip of what he's going to talk about, if you're on KVM, use Virtio to connect to your disks. It makes all the difference. So let's zoom in a little bit on the base OS. And I'm going to start with a very traditional roadmap slide. And it's going to be a little bit fuller than what we've done. Now I'm going to start with an apology because I stood here last year around this time of the year. And I told you that we would go to field test with version 9.2.4 in the middle of 2026, and that we would, at the end of 25, and that we would go to production in the middle of 26. That turned out to be too optimistic. The problem, the implementation of new TStack and iSCSI is going to take more time. And we probably have put something together that we could call a field test candidate by the end of the year if we wanted to cut a lot of corners. But that's not the business we're in. And I'm hoping that that's not the business that our customers. So we've gone back to the drawing board, and you may have noticed that a few months ago, the dates on our roadmap for this release disappeared and were replaced with TDP. So my apologies for that. What we are going to do is we are going to do an update 3 for OpenVMS version 9.2.3, and it will have a lot of improvements in the debugger. It will have some security improvements, improvements in IO drivers, in IO driver performance, and miscellaneous bug fixes. So this is like a really like a maintenance release or a maintenance update. We may follow that with an update 4. We don't quite know yet. That really depends on what we find, and if we find things that we don't want you to have to wait for for version 9.2.4. We may follow update 3 with an update 4. Version 9.2.4, our goal is to have a 6-month field test period preceding that, because there's going to be a lot in these new versions. And we're hoping that we can go to field test in 2026 and that we can go into production in 2027. But we're not putting a date on it yet because we have not completed our due diligence in figuring out exactly how we're going to do it and how much time that's going to take. I hope to have an update on that within the next couple of months, in which case we will put things on our website. But right now, I was hoping to be able to give you a date, but it's too early. So version 9.2.4 will have a new TCP/IP stack, TCP/IP version 7. I talked about it last year. What we're doing is we are looking at OpenVMS. The TCP/IP code is pretty old. It was code that we borrowed from 364 Unix, and that was the last time we got a code refresh from the BSD side was about 20 years. And the world has moved on. 20 years ago, what was the fastest network card you could get? I guess we got 1 gigabit network cards, but most of the world was on 10 and 100 megabit networks. So with 10, 40, 100 gigabit networks making their way into data centers, our current TCP/IP stack cannot keep up with that. And with more modern security protocols for performance, a lot of functionality is being pushed into the core of the TCP/IP kernel rather than all being done at the user layer. So in order to support things like WireGuards or NFS version 4, the old BSD network stack that we are currently running is really holding us back, making big strides there. So this is what TCP/IP 7 will bring. We will take a current version of the network stack, one of the BSDs. I believe we're taking FreeBSD. Yeah, pretty sure. So we're taking FreeBSD as it is today, and we are basically doing a report of the BSD stack to VMS. In the process, we're also making some changes to the what we call cradle that TCP/IP stack lives in. It's a set of routines in the VMS kernel that provide an environment that is BSD-like enough for that TCP/IP stack to be happy. We're making improvements to that mainly for performance, of course, to adapt to how BSD has evolved over the last 20 years. That is also to us an enabler for iSCSI, although we're starting to get confident that we can probably get iSCSI working on the existing TCP/IP stack as well, albeit without some of the potential future performance enhancements that we may be able to gain on TCP/IP version 7. Another thing that we want to bring to version 9.2.4 is timekeeping and graceful power operations in virtual machines. Right now, if you have a virtual machine and if you're on KVM and you go to the menu and you say shut it down, it works fine because KVM uses a standard ACPI mechanism for its power operations. If you go to an ESXi host and you go to the menu, there is no shutdown. There's only a power off. Shutdown is grayed out. Because if you want to shut down gracefully on ESXi, you need to have part of VMware tools installed. So our Greek team, they're sitting at the back. Stand up, guys. So this is the first project that our team in Greece has taken on in the base OS, and where we spent a lot of time thinking about this and trying to figure out how on earth does this work. They just went in and started prototyping, and yeah, they came up with a few things where we were like, well, that's not quite how we would like to see it integrated in the OS. They took that too hard, they adapted, and they came up with a product that we're going to be putting into OpenVMS version 9.4. And it's going to enable this. So it's going to enable graceful power operations on ESXi, and also both KVM and ESXi, they have implemented synchronization between the host and OpenVMS. And it's done in a way that is very VMS-like. You figure it, you can enable it, disable it, and if the time of the host changes, you can decide whether you want to have an abrupt change in your time of VMS or slew up to that, and how fast you want to do that. So so you now have a choice. You can keep using NTP or God forbid ETSS to keep your system synchronized with the world clock, or you can choose to go with the hypervisor, get to the time for the hypervisor route. It really depends on how you set up the rest of the infrastructure, what you want to do. So I'm very, very happy that they got that done. Signed execlets are going to be in version 9.2.4. What is signed execlets? It's the first step towards secure boot. And we may be able to pull off secure boot for version 9.2.4, but I'm not promising it because there's some hairy bits involved. But once we have all the parts in place, this becomes valuable. Because what secure boot does is we have our boot manager, and we will get our boot manager signed with a certificate that is recognized by the UEFI firmware as being secure. That means that if someone has tampered with the boot manager image to introduce a virus, do something malicious, the firmware will refuse to boot it, or at least give you a warning saying, hey, I have detected an invalid certificate, the checksum doesn't match. Do you really want to boot this or not? Then secure our boot manager, of course, loads sysboot. Now we're also eventually, and this is all part of this, eventually sysboot is going to be signed in a way that the boot manager can verify that sysboot is valid. The signed execlet parts of that is that the execlets get signed, and that sysboot will verify the signature of each execlet as it loads them into memory. And then when after that, any parts of the OS that get loaded into memory as part of the kernel will have a signature and will be verified by whatever part of the operating system loads it. That way, you have established a chain of trust all the way from the signature in the firmware to everything that is part of your running VMS kernel, so that you can be sure that if someone messes with system primitives.exe or rms.exe to introduce some code that doesn't come from us, your system will know about it and either refuse to boot or give you a warning depending on how you configure this. Like I said, we may not be able to have the whole chain in place. Version 9.4, we're going to do our best. PE driver compression on VAX, well, not on VAX, on Alpha and Artanium, PE driver can enable compression on cluster traffic if both nodes support it. On x86, this is something that we didn't implement. It's a bit of an oversight. We're going to enable that for version 9.4. We actually do a little bit of work for that, but get that done. We're also going to leverage another DORT.io device. This is DORT.io random. If you are on a platform that has a hardware random number generator, a lot of processors do these days, then DORT.io random is a way that you can get at that from a KVM guest operating system. So this will give you better entropy for your random pool at a lower cost. And we are looking at multi-factor authentication using Google Authenticate. This is still in its beginnings, but the people working on it, they feel that they can get this done. Following 19.4, we have another exciting thing to look forward to. Our native build. We have been working on our native build for a very long time. And as you can imagine, OpenVMS, with its pretty large code base, has a very intricate build procedure with lots of dependencies. Some of those dependencies are of a bit of a circular nature, which need to build something partly, then build something else that depends on that, and then build the original thing again, because now you can build it completely because it relies on something from the second one. Getting that working with like a completely native tool chain. And I know we have been telling customers you shouldn't use the cross compilers anymore for probably 2 years now. Well, we are still using them ourselves to build OpenVMS. And at some point, we would really like to stop doing that. For many years, we have been running like builds side by side. We're building our regular builds, and then about once a month, we build the operating system again with the native compilers. And it took a long time before we got to something that we could actually put. We got there. Then it took a long time until we got to something that we could install. Gotten there. Then it took a long time to get to something that didn't crash various teams. We've gotten there. We gotten to the point where we feel that we have a reasonably stable native build. Is it production quality yet? No. Are we getting really close? Yes. Are we starting to get to the point where we need help from customers, partners, ambassadors to sort out the last remaining issues? Probably. So what we want to do is when we go to production with version 9.4, pretty soon after that, we will start a field test for version 9.5. And version 9.5 is going to have exactly the same functionality as 9.4, but it will be a native build. How long will we be in field test with that? That depends on what you find and what we find. But when we get to the point where this is production quality, we will go to production using native compilers. And yes, after that, we will still be using cross compilers as well, because we have a commitment to support versions 9.3 and versions 9.4 with patches. And in OpenVMS, we built the patches with the tool chain that the OS was built with. That's important because if you introduce another compiler into the build chain, it may have unintended side effects other than the fact you're trying to fix this update. So I'm pretty excited about that. And there's been a bit of debate over the last few months whether or not we should announce this at the Bootcamp. But I felt that it was important to take you along on a journey. Thank you. Further on the horizon, and as you may notice, we're looking a little further ahead this year than we did last year. Last year, we were getting started with our product organization and like getting a grip on future plans. But now I can tell you a little bit about the next doc release, version 9.3. And I'm not putting any date on that yet, but this is what we want to do. So version 9.3, being a doc release, allows us to be a little more creative and break some things that we wouldn't necessarily break in dash release. And there is something that we want to break. What we want to break is cluster compatibility. hear me out. We don't want to do that for the sake of breaking cluster compatibility. But there are changes that we have been wanting to make for a very long time that we cannot make because they would break compatibility. So what are these things? There are two things that we really, really want to do. One is we want to have a better password hash algorithm. What we have today is, and I'm just going to say what we have is pathetic.
Thank you.
Is it good? Unfortunately, the system around that is robust enough that it's difficult to get at the CCUF of that. But once you have it, oh, if we want a better password hash mechanism, we need to make changes to a lot of different things. One of them is the cluster protocol. Another thing that we want to do is we want to improve the log manager by having a better resource hash algorithm. The algorithm we currently have with systems that have gotten much faster since the day of VAX, we see more clashes in our caching algorithm that we use within the log manager. So to improve the performance of the log manager, we really want a better hash. Memory is cheap. We can have larger hash tables, but it's the size of that field in various structures, including in the cluster protocol, that keep us from doing that. So this is something that we want to do. By necessity, that means breaking compatibility with clusters, with other cluster nodes. What we will do with version 9.3 is we will release a cluster compatibility kit, but we can only do that for VSI versions of OpenVMS. So this means no more HTTP versions of OpenVMS clustered together in a cluster with VMS version 9.3. And by extension, that means no more batches in a cluster. So my for architecture cluster at home will have to stay at VMS version 2 dash something. If we're breaking things, we are going to deprecate insecure protocols. When you set up a new system, running DECnet phase 4 is not going to be made impossible, but it's no longer running DECnet is no longer going to be the default outcome if you just enter your way through the installation. It will have to be a conscious choice during installation. And maybe even when you're upgrading an existing system, the installer will say something, notice that you're running DECnet. Do you really still need that? Because we think, and I know a lot of customers will keep running DECnet, and a lot of customers have set up DECnet phase 5 in a way that is reasonably secure. But we also believe that in a lot of cases, DECnet is installed simply because it was available and because it was default when the system was installed. We have come across customers that have DECnet installed, and their system is pretty much wide open through DECnet, and they're not using it for anything. They use SSH to get into the system. It's a standalone system. They don't use DECnet to communicate with anything. In that case, get rid of it. We want to make that easier, almost, than keep it. Also, things like Telnet and FTP. If you do an upgrade of TCP/IP, there will be like a little security for your system. That's how I envision it. Whether it will look like that, I don't know, but I could imagine like you upgrade TCP/IP and it notices you have Telnet. It will probably ask you, do you want to keep that or shall I make your system secure? SSH is how you should get into the VMS system. Encrypted cluster communications, that's another one that's on my wish list. The way we envision doing that is not reinventing solutions, but running DECnet over IP using IPsec or Wirecard. And that way you have a secure industry standard tunnel network cluster plan, rather than build something that may not be as. Yeah.
So when you talk about deprecating DECnet, you're talking about deprecating DECnet over the traditional protocols, but you'd still be able to have DECnet over IP phase 5?
So DECnet does not mean remove. You just want to hide it. So you go maybe instead of like hit enter and now you have DECnets, make you go through 2 questions for DECnet. It will still be available. We just recommend against
that idea. But I guess what I'm saying is the problem DECnet itself, the problem the legacy DECnet protocols that actually go with these systems.
It's
I think.
yes. Go ahead.
So the issue, yeah. So the issue is unencrypted protocol, right? So DECnet phase 5 is you are running phase 5 over secure, right? During phase DECnet phase 4 does not have this as an option, so that's why you would like DECnet phase 4 to go.
I understand.
Okay. DECnet phase 5 has the ability to run DECnet over IP, right? And you can secure your IP layer, in which case that's fine. So what we're trying to do is we're trying to take away as much as possible. We are understanding that there are going to be people for whom surrounding VMS systems with, putting it in essentially the whole system in isolation, cluster in isolation, is a perfectly valid solution to what you've had to do to this point. But we would like to remove the absolutely insecure protocol. So DECnet phase 5, DECnet phase 4 would be actively deprecated. DECnet phase 5 we'd rather you choose something else, but if that's what you need, and you can run it over secure IP and go.
But I think one of the points that trying to get at is, Camiel, you just said that in order to have encrypted cluster communications, you'd use DECnet. So that appears to be a contradiction.
No, IPsec.
Sorry. So
Yeah, that was my
Clusters over IP.
My comment, my question was, I heard the same thing as Nick did. You mean that you're basically shifting the LAN cluster traffic over IP, over an IP encrypted service.
Right.
Yeah. So
And
no DECnet.
misspeak on your part.
Okay.
With all due respect.
Apologies for the misspeak then. I have to keep going because we've been going for a while. I just felt it important that I mentioned these things. Version 8.4-3 is another thing that's new on this list. You've not seen this before, I hope. If you have, you were in our meeting last week and you're probably a colleague of mine. So we want to do, and I know that when we did 8.4.2.03, we said this would be the last version for Camiel we ever do. But we're going to do another version for Alpha as well as Titanium. It's going to be version 8.4-3. Now, don't get too excited. It's mostly going to be a roll-up of all the patches we've done today and all the system installed products that we've updated over the last few years. But we're also going to go through the changes we've made in our x86 versions, see if we can cherry pick a few select ones for backporting. If you have ideas on that, I'd like to hear them. Yep.
What about the Alpha EV7 flavor of OpenVMS?
I'll get to that. Yes.
How to improve this? library supports?
That's going to be more difficult, I think. We may be able to do a few things, but of course, a lot of the compiler and library work that we did for x86 was based on a completely different compiler backend. Nick.
Yeah, I know you've no dates on it. Do you have a rough idea? 1 year, 2 year?
So what we want to do first is we want to establish the scope by figuring out what improvements we want to backport. And we want to look at our release schedule. So our release schedule for x86 is going to be leading. When we find a hiatus that is sufficient for us to do like the testing and release management for this alpha version to do it, I expect to see this appear sometime in the next couple of years. Now, I would like there to be only one alpha version of this version of VMS. Right now, we are maintaining two versions for alpha. We're maintaining 842L1 and we're maintaining 842L2. The difference between that is that 842L2 uses instructions that are available on EV6 and later processors. If you look at our list of supported hardware, the oldest systems we support are the DS10 generation. Those have an EV6 processor. We do not officially support anything that doesn't have an EV6 or later processor. And all the emulators also provide EV6 or later instruction sets. I personally very much like to get rid of the non-EV6 build of the OS and give everyone the optimized build by default. You get a little higher performance and you don't have to keep it in two versions. If there's anyone in the room who is still running on an Alpha Server 1000 or maybe a DEC AXP 3000,
On the personal alpha workstation.
Personal workstations.
personal
Or
workstation
all EV4s.
on all.
They predate BS. They predate the EVs.
How many personal workstations are still in production use? If there are personal workstations in production use with any of your customers, tell me they're insane. I know of one place where that is in use, and I have told them they are insane, and I had to do it in French, which is different.
Then I've got a cluster that can join yours by 4100 Galaxy.
All right. Any questions on this one?
One question, I mean, I have one depends. Password hash algorithm and 93. What algorithm?
He can't tell you.
Allow me to
I
be,
have done for that.
allow me to rephrase. I would strongly urge the adoption of a standard hash, because when the auditors come a calling,
Yes.
being a NIST certified hash and documented appropriately will be the thing we should aim for is avoiding pain points of security audits.
Yes.
If it's a mystery hash, that's a big pain.
Yeah. This is one of the drivers behind it, because so I cannot tell you specifically which nest that might be able to, but it will definitely be something that is standard, industry standard, and recognized by certifying authority.
I've seen audits run into that thicket. And it's a thicket as a company, BSI should avoid at all costs.
I want to talk about an effort that we're taking within the OSC source base. We are taking select macro and maybe in the future also some risk modules and making an active effort to port them to C. And we're letting some of the newer generation of engineers do this under the supervision of the people who know this code. And we're doing this for 4 reasons. The first one is maintainability. Structured C code to a lot of people who do not have the kind of twisted mind some of us have, it's easier to understand, maintain, and change than macro code.
Oh, you mean I'm gonna use the value in that register that I left behind?
Exactly. Exactly.
Three,
Yes.
7.
Second reason, performance. With the new native compilers, and we're getting a newer LLVM backend sometime next year, these compilers can work miracles with C code. And I have seen optimizations come out of an LLVM backend that I, as an assembly language programmer, would never have thought. And you look at it and you're like, this is completely traced code. But yes, it saves few clock cycles. And if it's in a loop that's executed a million times, that's time. The other reason, macro talks to LLVM at a much lower level. It's much more like an assembler. And because of that reason, we need to, and we use these alpha pseudo registers because macro expects this register set. So we have this block of memory at each of 4 stacks that we use for those emulated alpha registers. Of course, they're going to end up in this good cache all of the time. So maybe the performance gain isn't that great, except of course that means that something else cannot be in that cache. So we expect some performance improvement from this effort. The team that works on this and works their way through a module, one routine at a time, taking in the macro code, translating it to C, first doing it like pretty much line by line or block by block, and then seeing, oh, this and this could be like a for loop. Okay, turn it into a for. Okay, some more manipulations. And now you end up with code that actually conveys what that routine is doing much better than the original macro code did. The macro code probably has some good comments to it, if you're lucky. If you're unlucky, it doesn't. But the team who does this now already knows this code. And if someone comes in with a request for an improvement or with a bug that is traced back to this code, we'll now have a younger generation of developers who already know this code and who can get working right away. So where are we doing this? We're looking at a few areas. We've already started the effort in DK driver. And DK driver, of course, is the SCSI class driver that is used for any pretty much any disk these days. There's no disk protocol that isn't in some way based on SCSI these days. And we're for iSCSI, for instance, we may have to make some modifications there. That's going to be easier to do when it's all in C. And we've identified some areas in memory management that are very heavy hitters, where we see some potential for performance gain by rewriting that in C. And the same goes for the I/O ticketing. Now, these are all pretty hairy areas of the OS to mess around. There are also areas in the OS where we still sometimes find day one bugs. And exactly that is why it's important that we do this. Because we need someone to be familiar with this code 10 years from now. When Brew Mason is going to end at the end of this year, and we have other people who know the memory management, but not as well as he did, so that will leave a bit of a hiatus. But 10 years from the line, no one who currently knows his code is going to be around anymore, is our expectation. Just because of the age of the people involved. And we want people who know this code to be around at that time. So that's why we're investing in this now. Moving on. And how am I doing for time? Oh, I really need to hurry up. I'll go quickly. I'm getting a lot of questions from customers recently, now that we are getting customers to production, with questions like, I'm running on KVM and Oracle Linux has just released a bunch of patches for Oracle Linux or for KVM. Is it safe to apply those? Will it affect the VMS system? And right now, we don't really know. That's a problem. We can tell customers what we are testing on, but we didn't have a setup where we validate every patch. And we've been thinking a lot about how we can tackle this. And there are, especially if you're using Fibre Channel Cluster, there are various software and firmware components in your chain. So you have your hypervisor. There is a VMware version, or there's a KVM and a Red Hat Enterprise Linux version. There are patches for that coming up pretty much daily. You have a hardware platform. You have an HPE system or a Dell system. There are firmware updates for that. You have your Fibre Channel HVAs. Occasionally, there's a firmware update for that. You have your Fibre Channel switches, whether they're from Brocade or Cisco or QLogic. Those have firmware on them. Those get patches. And then you have your storage arrays, whether they're from HPE or Dell or Pure. Lots of software and firmware components. And how are we going to keep track of that? Well, first of all, I want to focus on what is it that we need to be compatible with. And to do that, I want to examine the communications that there are between components. So OpenVMS as an operating system communicates with the hypervisor. The hypervisor communicates with the hardware platform. So we need to validate that we can run on a specific version of the hypervisor. And then it's the hypervisor that needs to be compatible with the hardware. But it gets more complicated once you start adding Fibre Channel path-through. So you add a Fibre Channel HVA to your system. That needs to be compatible with your hardware platform. Otherwise, things fall over. But Fibre Channel pass-through pretty much opens a hole in the hypervisor so that OpenVMS, in particular PGQ driver, now talks directly to this HVA. That means we need to be compatible with the firmware on that HVA. And then you add a Fibre Channel switch storage array. Fibre Channel switch needs to be able to communicate with your HVA as well as with the storage array. But there's also kind of a hole that goes through there because DK driver at the SCSI command and response level communicates directly with the storage array. So VMS also needs to be compatible with the storage array. But as you can see, the switch, that needs to be compatible with your HVA, it needs to be compatible with your storage array, but we don't care. As long as it passes those packets, we're fine. So the bits in red are the bits that we have a relationship with. So we care about the firmware and the software that makes up these three parts. So what are we going to do? What we're going to do is we are going to set up 3 systems in our lab, one for each of the hypervisors. Each of those systems will have one of each of our supported HVAs. The SN1100Q, the 1600Q, and the 1610Q. They'll be connected to a storage array, and on each of these systems, we will run various virtual machines. We're using all the different things in the hypervisor that we support. So we'll have virtual machines on KVM that use the emulated Intel NIC as well as ones that use the Virteo NIC. We will use, we will have virtual machines with SATA storage. We'll have them with parallel SCSI storage. We'll have them with Fibre Channel path-through. We'll have them with Virteo SCSI, so that we test all the different parts of this. And these systems, the VMware and KVM instances will be kept up to date with the latest patches. So we'll be on sort of like a nightly build stream where as soon as a patch is released, we install it. And then we run continuous testing. And anytime a firmware comes out from one of these HVAs, we install it as well. So every night we run our tests. And in the morning, there's a report that says green, everything works. or it's red. If it's green, we take the latest versions of any patches that have been installed and add them to our automatically kept list of what we know we are compatible with. If it's not, the first thing we do, if someone gets an alert, and we will send out a bulletin to all our customers saying, hey, we installed these patches and something broke. We don't know what yet, but please hold off on installing these patches in any of your systems until we have figured it out and can give you some better guidance. But
Two things. Finding commitment for yes or no on patches.
Yeah.
You need to know that it takes hours to the last. I recommend double the time you can spend just for sanity in case it's a glitch. Second thing is testing needs to include things like disconnection, physical disconnection. I've seen strange things happen when the path disappears.
I'll think about it.
Combinations of firmware update and drives going offline, that kind of a case tends to uncover strange microphone problems.
Well, part of this will definitely involve things like doing an installation, but we'll see. We have to come up with something that we can automate.
Agreed. Turning the switch on, putting switch ports on and off is probably sufficient.
Possible.
Breaking the path.
Noted. I have to keep going.
Yeah.
Then for storage arrays, we list the minimum firmware required on our website. And it's really up to the vendor to make sure that they do not break. What we really need from a storage array is this ability to set unit IDs. And we verify that there is a firmware from the vendor that has that. If the vendor then takes that ability away, all that show. That's something we cannot let it. Another thing we are going to do is we're going to be qualifying the HP NSA 2060 storage array and the HP Electra MP storage array. The former is probably going to be easy, and likely we can announce that we support that array pretty soon. HPE Electra MP is possibly going to require some engineering work in the multi-pathing code, because it does a Lua in a slightly different way than most arrays. One other thing we want to support is PVSCSI. That is the ESXi equivalent of Virtuosky. So it's a paravirtualized driver. We expect better disk throughput from that of ESXi. Our cloud offering, Rafael can tell you all about that. There will be a keynote session tomorrow morning in this room about cloud. I'm going to skip a few slides because I'm kind of running out of time, I'm afraid. And I really want to get to this slide. This is almost like an Apple moment. One more thing. VMS XD, it's been mentioned by Daria yesterday. And this is kind of what it looks like. I have a Linux command prompt. I run a command, and now I have a DCL prompt. And VMS XDE, there's going to be a session on it tomorrow morning. It's going to compete with the cloud session, so you'll have to pick and choose. But this is a development environment in Linux. And it gives you the ability to run pretty much all OpenVMS development tools, compiler, linker, debugger, librarian on Linux from a DCL prompt. And what's driving this, 90% of what we're seeing is real OpenVMS. We've taken execlets from OpenVMS and moved them to Linux with a small layer underneath to provide some compatibility. That means that your programmer who is new to VMS and who is struggling with learning lists and macros doesn't also have to struggle with learning a new editor or a new code management system. So this is something that we'll be offering as a development environment build a field test that will be announced tomorrow in the session. And if you want to play with this, play with it. If not, we're still. With that, and my apologies for not getting into the stuff beyond the base OS. I want to thank you for your attention and enjoy the rest of your conference.
Good.